Since the beginning of the pandemic, he's been teleworking, so he's been doing it from a restored 1976 trailer that he calls his mobile data science lab. But he lives near Ottawa, so it's getting kind of cold in there, so I'm not sure how much longer he's going to last. Everyone, please welcome Yvan to the stage.
Thank you. As Jared just mentioned, I work for the Department of National Defence in Canada. And today I'm going to talk to you about how we are increasingly using R for advanced analytics, and also show you some examples of projects that my team has done recently. But before, I know it was a recurring theme in some of the previous editions of this conference, but the military and defense organizations in general in many nations have a long tradition of data analytics. This is a picture of Dr. George Lindsay. He's considered to be the father of military operations research in Canada, and he's been leading the organization I work for almost 20 years, back in the 60s and the 70s. And just to give you an example of his work, during World War II, George Lindsay was working on predictors. Predictors are the fire control systems that were processing signals from the first generation of radars and using that data to predict the motion of German aircraft and shoot at them automatically. So predictors were initially mechanical systems before they became electronic. And that's how George Lindsay described them in a paper he wrote a few years before he passed. He said, today such problems would be classified as artificial intelligence. And he was right. I think some people would call that prescriptive analytics or automated decision making. But in fact, this was done in the early 1940s is pretty impressive. Another interesting fact, George Lindsay is also one of the fathers of Sabermetrics. So in the late 50s, he was already publishing papers on metrics that can be used to compare baseball players. That's 20 years before Bill James started to publish books on this, 45 years before Moneyball. So that's also very impressive. All that to say that data analytics is not exactly new to the defense community. Now, of course, what constitutes data analytics is something that is still a little bit debated. Some of my colleagues in D&D see analytics as this new great big thing. Others, based on examples like the one I just showed you, are asking, well, isn't it the same old thing that we have been doing for 75 years? And my answer to that is always yes and no. Because traditionally, when operational analysts in D&D apply their statistical expertise or their scientific expertise to a problem, they tend to produce a one-off analysis that gets to be published in a report or a paper or a briefing to a client. But data analysts in D&D rarely produce models that are deployed in our enterprise systems to be reused on a regular basis, or models that will transform new data coming in without having a scientist in the loop to process it or interpret it. And to me, that's what modern data science requires. That's what modern data analytics requires, being able to leverage a fairly large amount of data that we have in our systems, develop data products that will ultimately live on those systems, very often using cutting-edge tools and cutting-edge statistical techniques. And that's exactly what my team is doing. You can see us here in a picture taken before COVID. Since then, a few more people, including students, have joined the team. And I will show you in a minute some of the great work that they have been doing recently. Just to be clear, we're not the only data scientist in D&D, and we're not the only scientist in D&D to do machine learning. But we are the only team to be embedded with the Chief Data Officer's organization. And we're the only team focused on developing models that will ultimately be deployed in our enterprise systems for routine decision support. We don't want our models to be used exclusively by scientists. We want them to feed dashboards and applications that will be used in a recurring fashions by planners, decision makers. And that is really, it's a bit of a culture shift for us in D&D. It's also a culture shift from an IT standpoint. To be really effective at doing that kind of enterprise data analytics, you need the right tools and the right infrastructure. And most of the tools that we have been using historically in D&D for data analysis are not very well adapted to modern data science. So when this team was formed a few years ago, we made the deliberate choice to use almost exclusively open source tools for a number of reasons. But I can summarize these reasons maybe into one. As Wayne Gretzky said, one of our great Canadian heroes, skate where the puck is going to be, not where it has been. So that's true for hockey, but that's also true for IT as well. In the past, most of the data analysis that was done in D&D was done using commercial tools like these. But when it comes to developing and deploying advanced analytics models, these days, open source tools like R, Python, Spark are really the way to go. And I know I'm preaching to converted here, but I think it's a message that we need to keep relaying within our government organizations. It's not just a question of getting access to the most cutting edge tools. It's also a question of getting the best talent possible. And if you want to recruit good talent, you have to make these tools available within your organization and make them easy to use. That's easy to say, of course, but in practice, it's not so easy. There are often IT roadblocks, as a few people have already mentioned in this conference. What has been a game changer for us in D&D is getting access to commercial cloud. Access to cloud gave us amazing data science virtual machines, sandboxes, more computing power, GitLab servers to share our code, and also a means to deploy some of our models into production. And the good news is that in the Government of Canada, we have recently adopted a cloud-first strategy in which cloud is the preferred option for delivering IT services. So that will hopefully make the life a lot easier for all of the data scientists out there across the government. Okay, so let me now show you 3 projects that my team has been working on recently. I selected projects for which we have used R, but I also tried to select projects that I think will resonate the most with other government departments that are represented in this conference. Starting with some of the work we have done in support of Operation Laser. Operation Laser is the Canadian Armed Forces response to the pandemic, and a good part of it involves supporting other government departments and provincial governments requesting military assistance. So, for example, over the last few months, the Canadian Armed Forces have assisted remote communities in the north of the country. They were also asked to provide assistance in over 50 long-term care facilities in Ontario and Quebec to do all kinds of medical support and logistical support tasks. But of course, any good military operation starts with good planning and good intelligence. And at the very early stages of the pandemic, our medical intelligence staff was already trying to predict how the pandemic would progress and where requests for assistance would come from. And although there are quite a lot of models and dashboards available to do that these days, back in February, March, there was not that many tools available to provide that kind of information beyond maybe the dashboard from Johns Hopkins University. So what Talia Beach and my team did is to produce this animated map of the virus progression over time and space. And this was done using R and using open source data collected by the University of Toronto, open source shapefiles with postal code areas from Statistics Canada. And back in April, this was probably the most geographically detailed picture of how the virus was progressing in Canada. So that map became very popular very quickly within D&D and even with other government departments. And it has informed some of the planning decisions related to UpLaser. Initially, the map was just an animated GIF, but a few weeks after we released it, Talia embedded the map into an RShiny app, which enabled users to have more control on it, picking an exact date, zooming in on a specific region, And not only that, Thalia added some predictive component to the map, so the users can get an estimate of the number of new cases in each region up to 7 days into the future. So that was a pretty cool project. My second project that I want to show you is about March Madness. Unfortunately, it's not about basketball. It's about finance. Because you have to know that in the government of Canada, fiscal years are ending in March. And at the end of the fiscal year is when a lot of contracts with the government are ending. That's when a lot of goods and equipments are received. So it's not uncommon to see managers spend up to 20% or even 30% of their annual budgets during the very last month of the year. And that's why we call this March Madness. But often managers cannot spend all of their remaining budget in March because a contract may have been delayed or because a piece of equipment has not been delivered on time. And when that happens, it's often too late to reallocate the money elsewhere. So in an ideal world, you would like to predict early in the fiscal year, say after just 5 or 6 months, which managers will underspend, which managers may actually require more money, and reallocate your resources accordingly. Problem is, it's not that easy to predict how much money managers will spend early in the fiscal year. So what we have done here is try to leverage the huge amount of historical financial data that we have in D&D to better understand some of our spending patterns and use these patterns to make predictions. There are probably different techniques to do that, like time series analysis, for example. But the method we initially looked at is to build a regression model that predicts the amount spent at the end of the year based on a number of potential variables. For example, if you plot how much a certain manager has spent at the end of the fiscal year against how much he has spent after only 5 months, you see that there's clearly a relationship between these two things over the years, and you can exploit that relationship. You can do the same thing with other variables, how much money was committed, how much money was allocated, and you can build a pretty good linear model out of that, which is exactly what Chari Gunasekara in my team, and he's at this conference, that's what he has done. He built a regression model that he implemented into a Shiny app. Right now, this Shiny app is not directly connected to our financial system, but it can take data extracts from our financial system and generate pretty good forecasts in red there with the 95 confidence interval fairly early in the fiscal year. So this is just a prototype, but we are working with our financial branch to test it on different funds with a view of deploying that kind of statistical model directly into our financial systems in the future. My last example is about the Public Service Employee Survey. And this is a survey conducted every year in Canada to get the views of all the employees of the federal government about their workplaces. So it's a fairly comprehensive survey with over 180 questions that covers different themes like employee engagement, leadership, workplace, compensation, and so on. And the goal of the survey is really to allow the government departments to identify what they're doing well and what they're doing not so well in terms of managing their people. So all the departments have a close look at these results every year, and they develop action plans to address issues that are raised in this survey, which is good. But most departments at the moment are still analyzing the results in a very traditional fashion. So for example, they build dashboards and they look at where they're scoring high, where they're scoring low, how much their scores have changed since the last survey. And obviously that's a natural place to start, but it's not necessarily the optimal way of exploiting the data because this survey has a lot of questions. So it's often hard for the departments or the department branches to figure out what part of the results they really need to focus on. So one approach to that problem that we have successfully used in my branch of D&D is to do peer comparisons. So for example, if you take the score obtained by a branch to a specific question and you compare it to those of all the other branches in the government, you can quickly find if you are in the bottom 10% or in the top 10% of all the branches. So that's a very simple approach, but it tells you very quickly the kind of results that you should have a closer look at. And we have done dashboards to allow departments to do that kind of analysis very quickly. But even with that kind of tools, the results of the survey are not always easy to interpret or address because of how certain questions are framed. For example, one question of the survey is, I am satisfied with my department. And people have to answer on a numerical scale to what extent they agree or disagree with that statement. So if a department gets a low score on that question, how can you interpret that? How can you explain what causes employee dissatisfaction? And more importantly, what can you do about it? So that's something we've tried to answer as part of a project we did in collaboration with the National Research Council. We developed a new set of dashboards using R that first have a look at how the survey responses are correlated with each other. So in this case, we use a force layout algorithm in R to visualize the correlation matrix between the responses. And that allows us to spot very quickly what are the really central questions of the survey. For example, question 44, I am satisfied with my department. That's right in the middle there. Question 66, my workplace is psychologically healthy. Question 26, I am satisfied with the quality of the supervision I receive. These questions are strongly correlated to a lot of other questions in the survey, and you cannot just look at them in isolation. What you can do, however, is to, if you get a low score to these questions, you can try to understand what are the main influencers. And again, there are means to do that in R. You can build a causal graph that estimates the strength and the direction of the influence between different questions. So for example, in Q66, my workplace is psychologically healthy. You can see that's influenced by question 65 responses about awareness and mental health. It's influenced by also responses to question 4. I have support at work to balance my work and my personal life, or question 54, my department works hard to create a workplace that prevents harassment. That's really interesting because it's a little bit more clear and it's more actionable. I'm going to give you another example that is even more telling. You can use a machine learning approach to do a similar kind of analysis. If you look at question 26, I am satisfied with the quality of the supervision I receive, which is a very central question in the survey. You can train a random forest model to determine what are the top predictors of responses to that question. And if you look at the results, it tells you that the most important predictors are the responses to Q22. I receive useful feedback from my supervisor. Question 24, my supervisor keeps me informed about issues affecting my work. Question 6, I receive meaningful recognition for work well done, and so on. So again, my point here is that this kind of insight is useful and it's actionable, and it can inform action plans that will ultimately improve the general satisfaction of employees. And we develop dashboards in R, and also using a combination of R and Power BI that make that kind of analysis very easy and very quick to do. So just before I finish, very briefly, I want to mention some of the other projects my team has been doing recently using R. For example, we've done work with the Royal Navy about personnel enrollment and selection modeling. We've done work with our material branch on procurement cost forecasting. We're doing some work with our NATO allies, including the US, on predictive maintenance. And also, we did some work recently on supply chain forecasting, and a bunch of other exciting things in other languages like Python and commercial tools. But that there's a lot to be done in data science, and we don't have any kind of shortage of problems that we can work with. So on that note, I'd like to thank you again. Thank you, Jared, for the invitation, and have a good day.
I love that we got to see the trailer at the end there. As if the statistics wasn't good enough, we got to see his trailer. So that was pretty awesome. Okay, As promised, we are now going to do the